In this video, we're going to put everything together that we know about how to graph in quadratic functions and how to factor trinomials when leading coefficient is not equal to 1 in order for us to produce a graph for this trinomial when leading coefficients are not equal to 1. And in the instruction, there are some guidelines on how we can find the key points that are important for us to graph what values or what points to include in order to create our quadratic curve. And in part 8, we have this function f of x. To get us started, we want to first determine what's the y-intercept, what's the mirror point of the y-intercept vertex, then find the x-intercepts, and 2 additional symmetrical points in order to graph the function. And to get us started, we're going to start with the y-intercept. And to find the y-intercept, we're still doing the same thing as before with the understanding for y-intercept, the input has to be equal to 0. So f of 0 in this case would leave me with a constant term, -5. So that tells me the y-intercept is 0, -5. And I'm going to highlight all the key points I'm going to use at the end in order to graph it. Then we want to find the y-intercept's mirror point. But in order to find the mirror point, we actually need to know what's the axis of symmetry. Where is our mirror line? And to get us there, we can use the information we know about the x-coordinate of the vertex or the line equation of the line of symmetry over here, where we can think about the x is equal to -b/2a. And this can be used as part of the process for vertex as well. So I'm going to label as symmetry as /vertex. So the vertex has x-coordinate equal to -b/2a, which would be negative of -9/2a, so 2 times 2, and we get 9/4. And this is a good place for us to kind of think about all the pieces of information we had learned before and do a quick review and also combining the more recent knowledge together. And that tells me the axis of symmetry is positive 9/4. With this, we can also find the y-coordinate of the vertex. That means y would be equal to f of 9/4 over here. And plugging this in, when the input is 9/4, we have 2 times 9/4 squared minus 9 times 9/4, then minus 5. This is going to involve a lot of fractions, but that's okay. And we would have 2 times 81/16 minus 81/4 minus 5. And we have a little bit of cancellation. 2 and 16 cancel out to leave a factor of 8 in the denominator, meaning we would get 81/8 minus, here we have 81/4. So in order to get the least common denominator, I'm going to go ahead and multiply 2 on both sides. That would give me 8 in the denominator, so I can do subtraction easier later on. 81 times 2 is 162. And then minus 5 for the same argument, because 5 is technically 5/1. In order to go for the denominator equal to 8, I'm going to multiply 8 on both sides, which gives me 40/8. And now altogether, 81/8 minus 162/8 will be -81/8 minus 40/8, which would be -121/8 over here. This is probably going to be a point we'll have to eyeball a little bit when we start graphing this on the graph. And we find out that the vertex is going to fall at the point 9/4, 121/8. This is going to be the vertex. And then that tells me also where to find the mirror point of the y-intercept. In order to get this, I want to think about where the symmetry would fall on. And in this case, we can see that if I had 0, -5 to start with, and the axis of symmetry with x-coordinate being 9/4, I will have the mirror point of y-intercept to have the same y-coordinate because they're at the same height. So y-coordinate would stay the same, and the x-coordinate will just double the x-coordinate of the line of symmetry or the vertex x-coordinate. So 9/4 times 2 gives us 9/2 over here because they have to be equal distance away from each other. If again you need a reminder, what we did before is essentially saying if the x of symmetry is x equals 9/4 and y-intercept falling at 0, -5, they need to be equal distance away from each other. And with this 0 to 9/4 is 9/4 units plus another 9/4 would be 18/4 or 9/2 over here, be in the x-coordinate. And with this information, the y-coordinate should stay the same, so 9/2, -5, becomes a mirror point of the y-intercept. Over here. And then we want to go ahead and find the x-intercept in 2 additional points before we start graphing the function. So I'm going to go ahead and find the x-intercepts first. To find the x-intercept, I will need to do it by by grouping over here. And that tells me I want to use the AC method. So for the AC method, I want the product of the two numbers to be the product of a times c, which is 2 times -5 or -10. And if I have a product of -10, I also want the sum to be equal to b, which is equal to -9. And you can go through the order pair, the factor pairs of 10 and think about how you can get a combination. And eventually the two numbers that would work should be -10 and +1. Because -10 times 1 is -10, -10 plus 1 is -9. And as a result, I can rewrite f of x to be equal to 2x squared minus 10x plus 1x and -5. And grouping the first two together, last two together, connected by addition. The first group, they share a common factor of 2 and also x. Once I factor that out, I'm left with x minus 5. And from the second group, positive x and -5 don't share anything, so I just have plus x minus 5 over here. And even though there's nothing in front of the parentheses, I want you to remember there's technically a factor of 1, because a factor of 1 times anything just keeps that value. And with this, we can factor out x minus 5 as a common factor between the two groups, and I'm left with 2x from the first group and positive 1 from the second group. And that's going to help us find the x-intercept by using the zeroed product principle to set x minus 5 equals 0 or 2x plus 1 equals 0. And x is equal to 5 or 2x equals -1 or x is equal to -1/2. As a result, we would have the two x-intercepts over here being 5, 0 and -1/2, comma 0. These are the x-intercepts. Now that I have done all the required points, I have a little bit more freedom as to what points I want to choose to find the coordinates and also its corresponding mirror point, the symmetrical points over here. And just looking through the numbers I have, there are some flexibilities on what values I can choose. Just for simplicity reason, I'm going for x equal to 1 over here. And for the symmetric points, if we have x equal to 1, so these are like the additional points. If x equals 1, f of 1 is equal to 2 times 1 squared, which is 2, minus 9 times 1, which is 9, minus 5 over here. And altogether, I would get -7 minus 5, which is -12. So I know the point 1, -12 has to be on the graph. Again, utilizing this idea that if I want to find the symmetric point, 1, negative 12, let's say, is on one side of the x of symmetry, which is x equals 9/4. I know 1 is smaller than 9/4, so 1, negative 12 is somewhere here. And that distance away from x equals 9/4, if we just find the difference between the x coordinates, we would have 5/4, and that means I should have another 5/4 as the equal distance point. Once I add 5/4 to 9/4, I will get 14/4, or 7/2. So we're just adding this number and this number together. So 7/2, negative 12, meaning they're at the same height. So the other point will be 7/2 and negative 12 all together. And now my goal would just be go ahead and try to scale everything reasonably so I can fit all the points on the graph. And here I can see for the y coordinate, I think the largest value I have on the positive side is 121/8, and on the negative side I have to go all the way to negative 12. So let's see, we'd have 2, 4, 6, 8, 10, 12. So that would be negative 12 over here. I'm just going for each box being 1. And similarly, we can label the other side as 2, 4, etc. And on the x coordinate, I have a little bit more leeway as to what this looks like. So I'm okay with using multiple boxes representing one unit. So the largest x coordinate I have to incorporate will be, I believe, 5, 0. And I don't really have to worry too much about the negative coordinates. I don't have very negative x coordinates. So I'm going to go for every 2 boxes being 1. So that would be 5. And on the negative side, I would have negative 1 over here. So with a scale like this, we can start plotting the points on there. The first point is 0, negative 5, and we can go ahead and label the first few axes or tick marks. And the first point, y-intercept, is 0, negative 5, which will be right here. And then we have the vertex, which is 9/4, 121/8. This requires a little bit of a conversion. You can convert them to mixed numbers or decimals. 9/4 is 2 1/4, so 2 1/4 would be right around here, right, just slightly to the right of the value 2, halfway to the next box. And 121/8 is going to be a little bit over 15, and I might have to extend my y-axis a little bit over here. So let's see, if we had 6, 8, 10, 12, yeah, I'll have to extend it a little bit over here. And once I do so, I will have the point just slightly above the line of 15, because it's 15 1/8. So if we look at 2 1/4, 15 1/8 would be somewhere here in this case. And that's going to be the Actually, I just realized that the vertex should have a y-coordinate of negative 121/8. I completely dropped the negative sign for a minute, so it should really be below the x-axis. And we have 9/4, so 2 1/4 somewhere down here, and I want to draw it next to negative 15, just slightly below negative 15. So that should be where the vertex is. And next we have the point, the mirror point of y-intercept, which is 9/2, negative 5. 9/2 will be 4 1/2, and 4 1/2 will be right here, and it's the same height as a y-intercept, so it'll be right here. And then we want to go ahead and put in the 2 points that we picked were additional symmetric points. We had 1, -12. These numbers are chosen, so it's pretty easy to graph. And then we have 7/2, -12. So 7/2 will be 3.5. So 3 will be here, 3.5 at the same height will be right around here. And then for the x-intercepts, they need to stay on the x-axis. We have 5, 0, and -1/2, 0. So these are the x-intercepts. And we can see we have 7 points in this case, which gives us a pretty good idea for what the graph will look like. And if we connect all the points with a smooth curve as much as possible, we would see something like this over here. And this is going to be the graph of f of x. It keeps extending both directions.